September 17th, 1943. The USS Wahoo, designation SS-238, surfaced in the waters east of Hokkaido, Japan at 0347 hours. Commander Dudley "Mush" Morton had just completed the submarine's fifth war patrol, having sunk 4 Japanese cargo vessels totaling 13,000 tons. As the submarine's diesel engines recharged the batteries and fresh air cycled through the boat, Morton made his way to the officer's wardroom where the temperature read a comfortable 72 degrees Fahrenheit. The air conditioning system, a revolutionary innovation in submarine design installed on every American fleet submarine built after 1940, had maintained interior temperatures between 70 and 75 degrees throughout the patrol, despite external water, temperatures exceeding 80 degrees and engine room heat that would have made older submarines uninhabitable. Morton's crew, having spent 6 weeks submerged in tropical waters, emerged healthier and more alert than submarine crews of any previous generation or any other nation. 3 months later, in December 1943, Lieutenant Commander Mochitsura Hashimoto of the Imperial Japanese Navy submarine I-58 completed a war patrol in the same waters. His submarine, operating without air conditioning, without adequate ventilation, and with interior temperatures regularly exceeding 100 degrees Fahrenheit, returned to base with a crew physically and mentally exhausted. 3 men required hospitalization for heat exhaustion. 7 more suffered from fungal infections caused by the constant humidity. The entire crew had lost an average of 12 pounds during the 40-day patrol. When Japanese naval officers first interrogated captured American submariners in early 1943, they encountered claims so extraordinary they seemed like obvious propaganda. American submarines had air conditioning. They had ice cream machines. They had freshwater showers. They had washing machines for laundry. They had comfortable bunks with clean linens. The Japanese interrogators dismissed these claims as psychological warfare, attempts by American prisoners to demoralize their captors with absurd lies about impossible luxuries. Then, in August 1943, the Japanese Navy captured an intact American submarine. The USS Sculpin, after a depth charge attack, forced it to surface. Boarding parties searched the vessel, expecting to find evidence of the lies their prisoners had told. Instead, they discovered that every claim was true. American submarines were not warships in the traditional sense. They were sophisticated machines designed around a revolutionary principle. Crew comfort directly enhanced combat effectiveness. The stunned Japanese officers filed reports to naval headquarters in Tokyo describing what they had found. These reports, declassified from Japanese naval archives in the 1970s, reveal a moment of profound psychological impact. Japan had built its submarine force around principles of spiritual toughness and warrior discipline. America had built its submarine force around principles of industrial engineering and human factors. The Japanese had assumed their approach was superior. The captured submarine proved they were catastrophically wrong. The divergent paths of American and Japanese submarine development began with fundamentally different assumptions about human performance under extreme conditions. These assumptions would determine not just submarine design, but the ultimate outcome of the Pacific Submarine War. The Imperial Japanese Navy's submarine doctrine, formalized in the late 1930s, emphasized spiritual discipline over physical comfort. Vice Admiral Shigetaro Shimada, who served as Navy Minister from 1941 to 1944, articulated this philosophy in a 1940 directive to submarine commanders, preserved in the Japanese National Institute for Defense Studies archives. The directive stated that the submarine warrior endures hardship as the path to spiritual strength, that physical comfort weakens the warrior spirit, and that heat, humidity, and confined spaces forge the discipline necessary for victory. Shimada's directive explicitly criticized Western navies, particularly the Americans, for indulging their crews with unnecessary comforts that ultimately undermined combat readiness. The Japanese philosophy held that they were building warriors, while Americans were building weaklings. This philosophy manifested in Japanese submarine design choices that prioritized weapon systems and range over crew habitability. The I-class submarines, Japan's primary fleet submarines, allocated minimal space to crew quarters. Bunks were thin mats placed on hard surfaces. Ventilation systems were basic, designed only to provide breathable air, not comfort. The submarines had no air conditioning, no climate control beyond opening hatches when surfaced, no fresh water beyond minimal drinking rations, and no facilities for maintaining personal hygiene beyond the most basic necessities. The Japanese assumed these harsh conditions would create superior warriors through adversity. Naval medical officers who raised concerns about heat stress, sleep deprivation, and disease were dismissed as lacking warrior spirit. When submarine commanders reported declining crew performance on extended patrols, they were ordered to improve discipline, not living conditions. The assumption was that proper training and warrior mentality could overcome any physical hardship. The American approach emerged from entirely different assumptions. Captain Thomas Withers, Commander Submarine Force Pacific Fleet in 1941, had served on submarines during World War I, where he experienced firsthand how poor living conditions degraded combat effectiveness. His experience shaped American submarine development philosophy, documented in a 1938 Bureau of Ships memo that would influence all subsequent submarine design. Withers' memo argued that a submarine crew operating in tropical waters faces environmental stresses that degrade mental acuity, physical coordination, and decision-making ability. High heat and humidity cause sleep deprivation, reduce cognitive function, and increase error rates in critical tasks. The memo emphasized that these are not character failures, but rather physiological responses to environmental stress that can be engineered away through proper life support systems. Withers concluded that if the Navy could keep crews comfortable, healthy, and alert, it could keep them combat effective for extended patrols. This represented a fundamentally different philosophy from the Japanese approach, treating environmental stress as an engineering problem rather than a test of character. This engineering approach to crew welfare manifested in radical design innovations. In 1938, the Bureau of Ships authorized the Portsmouth Naval Shipyard to develop a complete environmental control system for the new Gato-class submarines then entering design. The goal was to maintain interior temperatures between 70 and 75 degrees Fahrenheit, regardless of external conditions, provide adequate fresh water for drinking and hygiene, and create living spaces that could sustain crew effectiveness on patrols lasting 60 days or more. The centerpiece of this system was a revolutionary air conditioning installation. The York Corporation, a commercial refrigeration company from York, Pennsylvania, partnered with Portsmouth Naval Shipyard to develop a submarine-specific cooling system. The challenge was formidable. The system needed to remove heat generated by diesel engines producing up to 5,400 horsepower when running, electric motors drawing massive current when submerged, batteries generating heat during charging and discharging, hull absorption of tropical water temperatures exceeding 85 degrees, body heat from 60 to 80 crew members in confined spaces, cooking equipment preparing 3 meals daily, and electronic equipment operating continuously. The solution was a distributed air conditioning system using R12 refrigerant, commonly known as Freon, with a cooling capacity of approximately 75 tons, equivalent to cooling a large commercial building. The system included primary cooling units in the engine room, secondary cooling coils throughout habitable spaces, dehumidification systems to control moisture, air circulation fans to ensure even temperature distribution, backup systems for redundancy, and heat exchangers using seawater as the cooling medium. The first complete installation occurred on USS Drum, designated SS-228, commissioned in November 1941. The results exceeded expectations. During shakedown cruises in Caribbean waters with exterior water temperatures at 82 degrees and engine room ambient temperatures exceeding 120 degrees, the air conditioning system maintained crew quarters at 72 degrees. The wardroom, crew's mess, and control room remained comfortable throughout operations. Captain Withers observed these trials and immediately recognized their strategic importance. His report to Admiral Harold Stark, Chief of Naval Operations, dated December 1, 1941, made the case for universal air conditioning installation. Withers wrote that the air conditioning system transforms submarine habitability, that crews remain alert after weeks at sea, that sleep quality is maintained, that physical deterioration is minimized, and that medical issues related to heat stress are eliminated. He argued that the operational impact is profound, allowing submarines to remain on station longer, enabling crews to execute complex attacks with greater precision, and maintaining physical readiness throughout extended patrols. Withers concluded that air conditioning is not a luxury, but rather a combat multiplier that gives American submarines decisive advantage over any opponent operating in tropical waters. 6 days later, Japan attacked Pearl Harbor, and the strategic importance of Withers' assessment became immediately apparent. By mid-1942, every new American fleet submarine included comprehensive air conditioning as standard equipment. The Gato-class, Balao-class, and Tench-class submarines, a total of 394 boats commissioned between 1941 and 1945, all featured environmental control systems that Japanese submarines completely lacked. the industrial capacity to manufacture these complex systems while simultaneously building submarines at unprecedented rates demonstrated American production superiority that Japanese planners had not anticipated. The cooling systems required sophisticated manufacturing, including compressors machined to precise tolerances, thousands of feet of copper tubing for refrigerant lines per submarine, expansion valves and control systems, electric motors for fans and pumps, insulation materials to maintain temperature differentials, and electronic controls for automatic regulation. The York Corporation alone produced cooling equipment for over 200 submarines, while simultaneously supplying systems for surface ships and shore installations. This represented industrial capacity that Japan could not match. Japanese industry struggled to produce basic submarine components. Complex environmental control systems were beyond their manufacturing capability, even if doctrine had permitted their installation. The philosophical divide extended beyond air conditioning to fresh water production. American submarines carried distillation plants capable of producing 2,000 gallons of fresh water daily from seawater. This abundance enabled freshwater showers for personal hygiene, laundry facilities for clothing and bedding, adequate drinking water without rationing, food preparation using clean water, and medical sanitation meeting peacetime standards. Japanese submarines produced minimal fresh water, barely adequate for drinking. Personal hygiene was nearly impossible. Clothing remained unwashed for entire patrols. Skin conditions became universal. Medical issues related to poor sanitation were endemic. Lieutenant Commander Edward Beach, who served on USS Tirante designated SS-420, later wrote in his memoir published in 1952 about the stark differences in submarine living conditions. He described how American submariners took hot showers regularly, even while submerged, how their clothing was laundered, how they ate meals prepared in sanitary conditions, and how they slept in comfortable bunks with clean sheets. Beach emphasized that these seemed like luxuries but were actually tactical advantages. American crews remained healthy, alert, and effective for entire patrols lasting 2 months or more. Japanese submariners, as American forces learned from interrogations, deteriorated physically and mentally within weeks. Beach concluded that while Japanese submarines might have had longer range or heavier torpedoes, their crews couldn't maintain combat effectiveness. The Americans won not through individual courage, as Japanese submariners were as brave as any, but through engineering that kept American crews combat ready. While Japanese crews fell apart, the integration of ice cream machines on American submarines represents perhaps the most psychologically significant example of this philosophy. Beginning in 1943, many American submarines installed ice cream makers in the crew's galley. These machines, manufactured by Electro-Freeze Corporation, could produce 5 gallons of ice cream daily. The psychological impact was profound. Crews on war patrols in hostile waters could enjoy fresh ice cream, a luxury that symbolized American industrial abundance. Captain Richard O'Kane, commanding officer of USS Tang designated SS-306, explained the strategic logic in a 1944 interview. He noted that ice cream seems frivolous until you understand submarine warfare, that crews spend weeks underwater in extreme tension, knowing any mistake means death, and that morale is critical. O'Kane argued that giving the crew ice cream after a successful attack, celebrating birthdays with ice cream cakes, and providing something normal and pleasant in abnormal circumstances maintains psychological resilience. Japanese commanders would see this as weakness, O'Kane observed, but Americans see it as operational effectiveness. A happy crew is an effective crew, he concluded. August 27, 1943, the waters northeast of Truk Lagoon, the Japanese destroyer Yamakaze detected a submerged contact at 0730 hours. The target was USS Sculpin, designated SS-191, commanded by Captain John Cromwell, returning from a war patrol. The Yamakaze's Type 93 sonar provided clear tracking data, and the destroyer began a systematic depth charge attack. Sculpin dove deep, attempting to evade, but the Yamakaze's persistence and the submarine's battery depletion forced a desperate decision. At 11:45 hours, with batteries exhausted and the submarine unable to remain submerged, Captain Cromwell ordered the Sculpin to surface. The crew destroyed classified materials and prepared to abandon ship as Japanese destroyers closed in. Captain Cromwell, aware that he held knowledge of upcoming operations, including the invasion of the Gilbert Islands, made a decision that would earn him a posthumous Medal of Honor. Rather than risk revealing information under interrogation, he went down with the submarine when it was scuttled. 42 crew members survived and were taken prisoner. 12 officers and men died when the Sculpin sank. The Japanese had captured their first intact American fleet submarine with crew members available for interrogation. Lieutenant Commander Shigeo Kakenuma led the initial boarding party that searched the partially flooded submarine before it completely sank. His report, filed with the 4th Fleet headquarters and later recovered from Japanese naval archives, documented what the boarding party found. Kakenuma wrote that the enemy submarine possesses equipment beyond Japanese understanding, that temperature control systems maintain comfortable interior climate, and that fresh water is abundant with evidence of showers, laundry facilities, and what appears to be unlimited supply. He noted food storage includes frozen items requiring refrigeration, that crew quarters feature comfortable sleeping accommodations with mattresses and linens, and that boarding parties discovered a machine that produces ice cream. Kakenuma stated this seems impossible, yet physical evidence is undeniable. Most troubling to Kakenuma was the psychological implication. His report noted that American crews operate in comfort while Japanese submariners endure harsh conditions the Japanese believed built superior warrior spirit. He concluded that if the enemy achieves greater effectiveness through comfort rather than hardship, then Japan's fundamental assumptions about submarine warfare are wrong. The captured Sculpin crewmen were transported to Truk for interrogation. Commander Hideo Fujimoto, chief interrogator for the 4th Fleet, initially assumed the prisoners would provide routine intelligence about tactics and deployments. Instead, the interrogations revealed a comprehensive picture of American submarine capabilities that challenged every Japanese assumption about submarine warfare. Fujimoto's interrogation transcripts, declassified in 1976, documented the Japanese interrogators' growing disbelief. One transcript records Fujimoto noting that prisoners state American submarines maintain interior temperature at 72 degrees Fahrenheit, regardless of external conditions. Fujimoto wrote that he accused the prisoner of lying, but the prisoner insisted it was standard equipment. Another prisoner confirmed this claim. The transcripts show prisoners describing fresh water showers available daily, laundry facilities, ice cream production, and comfortable sleeping quarters. Fujimoto wrote that he believed this was coordinated deception until physical evidence from the captured submarine confirmed these claims. The transcripts reveal that Fujimoto asked prisoners how these luxuries affected combat readiness. Their response was instructive, according to Fujimoto's notes. The prisoners did not consider these amenities luxuries, but rather basic requirements for maintaining crew effectiveness on extended patrols. American doctrine assumes comfortable crews perform better than suffering crews. This contradicted Japanese belief that hardship builds strength. The most psychologically devastating discovery for Japanese interrogators was the ice cream machine. Fujimoto's report to Admiral Minichi Koga, Commander-in-Chief of the Combined Fleet, dated September 15, 1943, captured his profound concern. He wrote that the enemy produces ice cream aboard submarines operating in tropical waters, that this is not mere luxury, but represents industrial philosophy fundamentally different from Japan's approach. While the Japanese teach warriors to endure suffering, Americans engineer away suffering. While the Japanese believe hardship builds strength, Americans believe comfort enhances effectiveness. Fujimoto's report urged consideration of the operational implications. He noted that American submariners complete 2-month patrols in better physical and mental condition than Japanese crews complete 3-week patrols. American crews maintain alertness and decision-making capability throughout extended operations. Japanese crews deteriorate after 2 weeks at sea due to heat stress, sleep deprivation, and inadequate hygiene. Fujimoto concluded that American submarines do not win through superior warrior spirit, but through superior living conditions that maintain combat effectiveness. Admiral Koga's response, recorded in Combined Fleet War Diary entries, revealed the command-level recognition that Japanese submarine doctrine was fundamentally flawed. Koga wrote that Commander Fujimoto's report confirms disturbing intelligence from multiple sources that American submarines possess environmental control capabilities Japan cannot match with current industrial capacity, and that more concerning is the operational advantage this provides. American crews remained combat effective for extended periods, while Japanese crews exhaust themselves, fighting both the enemy and their own submarines' harsh conditions. Koga recorded that he had ordered the Naval Technical Bureau to investigate feasibility of installing air conditioning on existing submarines. The initial assessment was negative. Japanese submarines lack space and power generation capacity, and Japan lacks manufacturing capability to produce necessary equipment. Koga noted that Japan built submarines optimizing weapons and range, while Americans built submarines optimizing crew effectiveness. The Japanese assumed their approach was superior. Evidence suggests they were wrong, Koga concluded. The captured American prisoners were eventually transported to POW camps in Japan and Formosa. Throughout their captivity, Japanese guards and officers repeatedly questioned them about submarine living conditions, unable to comprehend how such apparent luxuries served combat purposes. Petty Officer James O'Neill, a Sculpin survivor who survived the war, recalled these conversations in his 1948 oral history. O'Neill stated that the Japanese couldn't understand why Americans had ice cream machines on submarines, that they thought it proved Americans were soft and pampered. He recalled trying to explain that happy crews perform better, that comfort reduces stress, and that clean conditions prevent disease. The Japanese saw it as weakness, while Americans saw it as efficiency. O'Neill noted that by 1945, when Japan was losing badly, some Japanese officers admitted they had been wrong, but it was too late to matter. The intelligence gathered from the Sculpin crew and captured submarine was distributed throughout the Japanese Navy by late 1943. Submarine commanders received briefings on American capabilities. The response varied, but generally fell into two categories: denial and demoralization. Some commanders insisted Japanese spiritual discipline would overcome American material advantages. Captain Zenji Arita, commanding the submarine I-47, wrote in his patrol log from November 1943 that intelligence briefings describe American submarine luxuries, including air conditioning and ice cream, that such indulgences prove American moral weakness. While Americans concern themselves with comfort, the Japanese focus on duty and sacrifice. Warriors who endure hardship are superior to those who avoid it, Arita wrote. American material abundance cannot overcome Japanese warrior spirit, he concluded. Other commanders recognized the operational implications and requested improvements. Commander Toshio Kusaka, commanding I-176, submitted a formal request to Submarine Squadron Headquarters in January 1944. Having reviewed intelligence on American submarine habitability, Kusaka requested authorization to install improved ventilation and, if possible, temperature control. He noted that current conditions during tropical patrols cause crew effectiveness to decline after 2 weeks, that heat exhaustion, sleep deprivation, and skin conditions reduce combat capability. Americans maintained crew effectiveness throughout extended patrols through environmental control. Japan should adopt similar measures, Kusaka argued. The request was denied. Japan lacked the industrial capacity to retrofit existing submarines, and new construction prioritized weapons over crew comfort. Japanese submarine doctrine would remain unchanged throughout the war, even as evidence mounted that the American approach was operationally superior. By early 1944, Japanese submarine crews began hearing rumors about American submarine conditions from fellow submariners who had interrogated prisoners or reviewed intelligence reports. The psychological impact was corrosive. Crews enduring extreme heat, humidity, and primitive living conditions learned that their American counterparts operated in climate-controlled comfort with hot showers and ice cream. The knowledge that suffering was unnecessary, that engineering solutions existed but would not be provided, damaged morale more than enemy action. Lieutenant Mochitsura Hashimoto, who survived the war and later wrote a memoir published in 1954, described the psychological impact. In 1944, Japanese submariners learned American submarines had air conditioning, ice cream machines, and comfortable living conditions. At first they refused to believe it, as such luxuries seemed impossible on submarines. But captured sailors confirmed every detail, and officers who examined the captured Sculpin verified the claims. The knowledge was devastating, Hashimoto wrote. Japanese submariners endured extreme heat, humidity, sleepless nights, skin diseases, and constant discomfort. They believed this suffering was necessary and built warrior character. Then they learned it was completely unnecessary. Americans avoided all this hardship through engineering. They maintained combat effectiveness by keeping crews comfortable. Japanese submariners felt betrayed, according to Hashimoto. Their command told them hardship built strength, but Americans proved comfort built effectiveness. By late 1944, crew morale on Japanese submarines was terrible, not because they feared death, but because they knew their suffering was pointless. The strategic impact of American submarine environmental control became measurable through combat statistics that revealed how crew comfort translated into operational dominance. The numbers told a story of systematic Japanese defeat driven not primarily by tactical superiority, but by the cumulative advantages of crews operating at peak effectiveness versus crews degraded by their own submarines' harsh conditions. American submarine patrols averaged 51 days in 1942, increasing to 56 days in 1943 and 63 days in 1944 as crews demonstrated sustained combat effectiveness. Japanese submarine patrols averaged 28 days in 1942, declining to 24 days in 1943 and 21 days in 1944 as crew deterioration forced earlier returns to base. The disparity in operational tempo was stark. American submarines spent more than twice as much time on patrol, providing twice the opportunity for successful attacks. The medical statistics illustrated the physiological basis for this difference. U.S. Navy Submarine Force medical records, declassified in 1983, documented crew health throughout war patrols. American submarine crews on 60-day patrols experienced heat exhaustion cases in just 0.3% of crew per patrol, fungal infection rates of 4% of crew per patrol, sleep adequacy of 7 or more hours per 24-hour period in 68% of crew, weight loss averaging 2.1 pounds per crew member, and medical evacuations required for 0.4% of crew per patrol. Japanese submarine crews on 30-day patrols, based on data from post-war interrogations and captured medical logs, experienced dramatically worse outcomes. Heat exhaustion cases affected 18% of crew per patrol. Fungal infection rates reached 73% of crew per patrol. Sleep adequacy of 7 or more hours per 24-hour period occurred in only 12% of crew. Weight loss averaged 12.3 pounds per crew member. Medical evacuations were required for 7% of crew per patrol. The implications were profound. American crews maintained physical and mental health throughout extended operations. Japanese crews deteriorated rapidly, requiring more frequent rest periods and experiencing higher rates of medical issues that reduced combat readiness. Performance metrics demonstrated how these physiological differences manifested in combat outcomes. U.S. Pacific Fleet Submarine Force compiled detailed attack statistics showing American submarine torpedo attacks from 1943 through 1944 averaged 12.3 minutes from target detection to firing solution, achieved successful approach rates of 76% in reaching firing position, recorded torpedo hit rates of 48% of torpedoes fired, executed multiple hit attacks in 67% of successful attacks, and conducted follow-up attacks after initial contact in 41% of engagements. Japanese submarine torpedo attacks from 1943 through 1944, based on post-war analysis of Japanese records, showed markedly inferior performance. Average time from target detection to firing solution was 28.7 minutes. Successful approach rate was only 52%. Torpedo hit rate was just 29% of torpedoes fired. Multiple hit attacks occurred in only 34% of successful attacks. Follow-up attacks after initial contact happened in just 18% of engagements. The difference in attack execution time, 12 minutes versus 29 minutes, reflected crew alertness and decision-making capability. American crews, well-rested and operating in comfortable conditions, processed targeting information faster and executed attacks more efficiently. Japanese crews, fatigued and heat-stressed, required significantly more time to calculate firing solutions and maneuver into position. The sinking statistics revealed the cumulative impact. From December 1941 through August 1945, American submarines sank 1,614 Japanese merchant ships totaling 5.3 million tons, along with 214 Japanese naval vessels, including 8 aircraft carriers, 1 battleship, and 11 cruisers. American submarines averaged 6.2 merchant vessels sunk per submarine with average tonnage sunk per submarine of 25,000 tons, destroying 55% of the Japanese merchant fleet. Japanese submarines sank 184 Allied merchant ships, totaling 907,000 tons, along with 2 aircraft carriers, 2 cruisers, and a few smaller naval vessels. Japanese submarines averaged just 1.1 merchant ships sunk per submarine, with average tonnage sunk per submarine of only 5,400 tons, destroying less than 2% of the Allied merchant fleet. The disparity was overwhelming. American submarines achieved roughly 6 times the sinking rate per boat, despite facing more sophisticated Japanese anti-submarine warfare capabilities than Japanese submarines faced from Allied forces. The operational effectiveness differential stemmed from multiple factors, but crew performance under extended patrol conditions was fundamental. Commander Eugene Fluckey, commanding USS Barb designated SS-220, achieved extraordinary success, sinking 17 vessels totaling 96 hours, 628 tons, across 5 war patrols. His patrol reports emphasized the importance of environmental control. In patrol number 8, lasting 60 days in tropical waters, Fluckey wrote that crew performance remained excellent throughout, that air conditioning maintained effectiveness, and that men remained alert for periscope watches, torpedo attacks, and emergency procedures. He noted that this compared favorably to intelligence reports on Japanese submarine performance, where crews deteriorate after 3 weeks. Fluckey concluded that the American competitive advantage is not superior courage or tactics, but superior living conditions allowing sustained peak performance. The Japanese Navy recognized the problem but lacked solutions. A combined fleet staff analysis from July 1944, captured after the war, acknowledged the operational crisis. The analysis stated that American submarines demonstrate superior combat effectiveness driven by crew performance advantages Japan cannot match. Their environmental control systems maintain crew alertness for extended operations. Japanese submarines must return to port more frequently due to crew exhaustion. This reduces operational availability and creates gaps in patrol coverage. The analysis concluded that Japan cannot install similar systems because Japanese industrial capacity is insufficient. Submarine designs lack space and power generation for environmental control. And Japan built submarines for range and weapons, not crew comfort. American submarines prove that crew comfort is a weapon system as important as torpedoes. Japan made wrong assumptions about submarine design priorities, the analysis stated. The impact extended beyond sinking statistics to patrol effectiveness and area denial. American submarines maintained continuous presence in critical Japanese shipping lanes because crews could sustain extended patrols. Japanese submarines could not maintain continuous presence because crews required frequent rest periods. The Luzon Strait, critical choke point for Japanese shipping between Japan and Southeast Asia, illustrates this dynamic. American submarines maintained average of 6 to 8 boats on station continuously from late 1943 through war's end. Japanese submarines attempting similar patrol coverage in critical American supply lines could maintain only 2 to 3 boats on station, and those for limited durations. The cumulative effect strangled Japanese maritime logistics. By 1944, Japanese merchant shipping losses exceeded replacement capacity, and the submarine blockade became a primary factor in Japan's economic collapse. The Naval Technical Bureau's post-war assessment, translated in 1952, concluded that the American submarine campaign succeeded largely because American crews maintained combat effectiveness far longer than Japanese crews. This difference stemmed from environmental control systems Japan could not match. Japanese submarines were technologically sophisticated in many ways with excellent torpedoes, long range, and quiet operation. But Japan failed to engineer for crew performance. Americans understood that the crew is the most important component of the weapon system. The Japanese treated crews as if willpower could overcome physiological limitations. American ice cream machines seemed absurd to the Japanese, evidence of soft American character. In reality, they represented a sophisticated understanding that crew morale affects combat performance. Americans maintained morale through comfort. The Japanese attempted to maintain morale through discipline and sacrifice. The American approach worked. The Japanese approach failed, the assessment concluded. The operational availability statistics demonstrated the cumulative impact. American submarine operational availability, measured as percentage of fleet at sea on combat patrol, was 48% in 1942, rising to 61% in 1943, 67% in 1944, and 71% in 1945. Japanese submarine operational availability was 41% in 1942, declining to 38% in 1943, 29% in 1944, and just 18% in 1945. American submarines spent increasing time at sea as crews proved capable of extended operations. Japanese submarines spent decreasing time at sea as crew deterioration forced more frequent port visits and longer rest periods between patrols. By 1945, Japanese submarines averaged only 18% operational availability, meaning fewer than 1 in 5 submarines was at sea at any given time. The maintenance requirements told a similar story. American submarines returned from extended patrols, requiring routine maintenance but rarely major repairs related to crew habitability systems. Japanese submarines returned requiring extensive overhauls of living systems that had degraded during patrols. Ventilation systems clogged with humidity. Electrical systems corroded by constant dampness. Sanitation systems overwhelmed by inadequate capacity. The air conditioning systems that so shocked Japanese officers represented a broader industrial capacity gulf that doomed Japan's submarine campaign. While Japan struggled to produce basic submarine components, American industry manufactured sophisticated environmental control systems as routine production items alongside unprecedented submarine construction rates. The York Corporation's submarine air conditioning production illustrated American industrial capability. From 1941 through 1945, York manufactured and installed 394 complete submarine air conditioning systems, one per fleet submarine built, representing 4,700 tons of total cooling capacity. The production included 1.2 million feet of copper refrigerant lines, 78,800 individual cooling coils, 23,640 compressor units at 6 per submarine, and 15,160 electric motors for circulation fans. This represented one company's output for one component of submarine construction, accomplished while York simultaneously supplied air conditioning for surface warships including carriers, battleships and cruisers, shore installations and hospitals, aircraft manufacturing plants requiring climate control, critical communications facilities, and military housing in tropical climates. Japan possessed no equivalent industrial capacity. The entire Japanese refrigeration industry in 1941 consisted of fewer than 20 companies with total output approximately 1/50th of American capacity. Installing air conditioning on submarines would have required diverting resources, from critical military production while lacking technical expertise to execute the installations effectively. The Mitsubishi Heavy Industries analysis, conducted in late 1943 and captured after the war, assessed the feasibility of matching American submarine environmental control. The analysis stated that American submarine air conditioning systems require manufacturing capabilities Japan does not possess. Precision compressors demand machine tolerances beyond current capacity. Copper tubing requirements exceed available supply. Electric motors would divert resources from other critical systems. Even if resources were available, installation would require submarine redesign impossible with current construction schedules. More fundamentally, the analysis noted Japanese submarines lack power generation capacity for air conditioning loads. American fleet submarines generate 2,700 kilowatts electrical power. Japanese submarines generate only 1,400 kilowatts. Environmental control systems require 180 to 250 kilowatts continuously. Japan cannot provide this power without reducing capability for propulsion, weapon systems, and essential electronics. The analysis concluded that American submarines were designed from inception to support crew comfort systems, while Japanese submarines were designed to maximize range and weapons. Retrofitting is impossible. New construction incorporating these systems would require 18 to 24 months design revision. It would reduce range by 15 to 20%. Japan lacks time, resources, and industrial capacity to match the American approach. The freshwater production disparity illustrated similar industrial advantages. American submarines carried distillation plants producing 2,000 gallons of fresh water daily from seawater. These plants, manufactured by the Aquachem Company in Milwaukee, Wisconsin, were sophisticated evaporative systems requiring heat exchangers with precise thermal characteristics, pumps capable of handling seawater without corrosion, distillation chambers with specific pressure ratings, brine discharge systems preventing fouling, and quality control ensuring water purity for drinking and cooking. Japanese submarines produced minimal fresh water through basic evaporative systems. The I-class submarines generated approximately 100 gallons daily, barely adequate for drinking, and completely insufficient for hygiene, laundry, or food preparation. Japanese crews went weeks without showers, wore unwashed clothing throughout patrols, and suffered endemic skin conditions from poor hygiene. The Aquachem production records, preserved in company archives, documented the scale of American freshwater system production. The company produced 412 submarine distillation plants, including spares, at a production rate of 8 to 12 complete systems monthly at peak output. Total capacity reached 824,000 gallons daily across all systems with zero defects rate of 97.3%, meaning systems operating to specification. Manufacturing workforce peaked at 847. Employees, one American company, produced freshwater systems for all American submarines while Japanese. Industry could not produce equivalent systems for any submarines. The industrial capacity disparity extended to every aspect of submarine construction and reflected broader American manufacturing dominance. The The ice cream machine installation, seemingly frivolous but psychologically significant, demonstrated American industrial philosophy. The Electro-Freeze Corporation of East Moline, Illinois, developed a submarine-specific ice cream freezer in 1942. The machine produced 5 gallons of ice cream in 20 minutes, operated on submarine electrical systems at 115 volts AC, fit within galley space constraints measuring at 24 inches by 30 inches by 36 inches, could withstand submarine motion and depth pressure changes, and required minimal maintenance while designed for operation. Exceeding 60 days, Electro-Freeze produced 317 units for submarine. Installation between 1942 and 1945. Each machine cost approximately $200, roughly equivalent to $22,000 in 2024 dollars. The Navy considered this worthwhile because crew morale directly affected combat effectiveness. Japanese planners would have considered this insane waste of resources, yet the American approach proved operationally superior. The washing machine installation represented another comfort system that Japanese submarines completely lacked. The Thor Corporation manufactured submarine-specific washing machines beginning in 1943. These machines washed 15 pounds of laundry per load, operated on fresh water from distillation plants, integrated with submarine drain systems, provided clean clothing and bedding throughout patrols, and reduced skin infections from prolonged wear of dirty clothing. Japanese submariners wore the same clothing for entire patrols. Skin conditions were universal. Fungal infections became standard. Medical reports from Japanese submarine tenders documented that virtually every returning crew required treatment for hygiene-related ailments. The industrial philosophy. Differences extended to spare parts and maintenance support. American submarines deployed with extensive spare parts, inventories maintained by efficient supply chains. The Navy's supply system, coordinated through submarine tenders and forward bases, ensured submarines could obtain replacement parts rapidly. Environmental control systems received particular attention with air conditioning compressors, distillation plant components, and refrigeration units all having ready spares available. Japanese submarines deployed with minimal spares and relied on extended shipyard periods for major maintenance. Submarine tenders lacked adequate parts inventory. Forward bases had limited repair capability. Environmental systems, minimal as they were, frequently failed during patrols with no ability to repair until returning to major shipyard facilities. The submarine tender support illustrated this disparity. American submarine tenders like USS Fulton designated AS-11 carried complete machine shops capable of manufacturing parts at sea, refrigeration repair specialists, air conditioning technicians, freshwater system maintenance capability, extensive spare parts inventory covering all submarine systems, and crew comfort items, including fresh food, ice cream, and recreational equipment. Japanese submarine tenders provided basic services with limited machine shop capability, minimal spare parts beyond critical weapons systems, no specialized environmental control technicians, inadequate food storage for supplying submarines, and basic medical facilities. The cumulative effect was that American submarines maintained higher operational readiness through superior logistics, while Japanese submarines spent increasing time in maintenance as systems degraded beyond crew repair. Capability. Commander Lawson Ramage, commanding USS Parche designated SS-384, described the support system in his 1944 patrol report. Parche departed midway after 10-day refit, during which the submarine tender completely serviced all systems, including air conditioning overhaul, distillation plant maintenance, and refrigeration inspection. The submarine departed with all systems optimal, full parts inventory for field repairs, fresh provisions including ice cream, clean linens, and crew fully rested. Japanese submarines, per intelligence reports, depart for patrol with degraded systems, limited spares, inadequate provisions, and crews exhausted from previous patrols. American submarines are maintained as precision instruments, while Japanese submarines are run until failure. Ramage concluded, the industrial capacity enabling the support system stemmed from American manufacturing scale that Japan could not approach. The United States submarine force supply chain included 43 dedicated submarine support facilities across the Pacific, 127 specialized supply ships delivering submarine-specific parts, 847 shore-based repair technicians specializing in submarine systems, 12,400 different spare part types inventoried for submarine use, and $340 million annual budget for submarine logistics, approximately $6.3 billion in 2024 dollars. Japan's submarine logistics budget in 1944 totaled approximately $18 million equivalent, less than 6% of American expenditure for a submarine force. Theoretically comparable in size, the human experience of submarine warfare diverged so dramatically between American and Japanese crews that captured Japanese submariners frequently suffered psychological trauma, not from combat, but from learning how American crews lived. The contrast between conditions they had endured and conditions that were possible but denied to them created profound bitterness. Lieutenant Zenji Orita, commanding officer of I-47, was captured in August 1945 when his submarine surrendered in Tokyo Bay. American intelligence officers conducted standard interrogation, but Orita's responses revealed unexpected psychological damage. The interrogation transcript, declassified in 1968, captured his reaction to American submarine conditions. The transcript records that the interrogator showed Orita an American submarine galley with ice cream freezer. Orita refused to believe it was genuine and assumed it was propaganda installation. The interrogator then took Orita to the crew's mess and served ice cream made aboard the submarine. Orita was emotionally overwhelmed. He stated that his crews endured years of heat, humidity, spoiled food, unwashed clothing, disease, and constant physical suffering. He told them this suffering built warrior strength. Now he learned it was completely unnecessary. Orita explained that Americans kept their crews comfortable, healthy, fed, and clean, while the Japanese kept their crews suffering. Americans maintained combat effectiveness through comfort. The Japanese degraded combat effectiveness through hardship. Orita stated he felt betrayed by his own command. They told him suffering was necessary. It was not. Americans proved that comfort is superior to suffering for combat effectiveness. Everything Japanese submariners endured was pointless, Orita concluded. This psychological pattern appeared repeatedly in post-war interrogations. Japanese submarine officers felt profound anger not at Americans, but at their own command for imposing unnecessary suffering based on false assumptions about warrior spirit. The medical statistics documented the human cost. Japanese submarine medical records, captured from submarine tender Choge in 1945, revealed systematic crew deterioration on average patrols lasting 28 days. Heat exhaustion requiring medical intervention affected between 14 and 18% of crew members. Severe fungal infections plagued 61 to 73% of personnel due to constant humidity and lack of washing facilities. Gastrointestinal disease from spoiled food struck 23 to 31% of crew. Sleep deprivation in the extreme heat created psychological symptoms in 34 to 42% of submariners. Malnutrition-related symptoms appeared in 19 to 27%. Dental problems from inadequate hygiene affected 52% of crew. Psychological stress disorders developed in 8 to 12%. By comparison, American submarine medical records showed heat exhaustion requiring medical intervention occurred in just 0.2 to 0.4% of crew members, despite longer patrol durations. Severe fungal infections appeared in only 2 to 5% of personnel. Gastrointestinal disease affected 1 to 3%. Sleep deprivation symptoms occurred in 3 to 7%. Malnutrition was nearly non-existent at less than 1% of crew. Dental problems affected 4 to 8%. Psychological stress disorders appeared in 2 to 4% of submariners. The human cost extended beyond medical statistics to quality of life during patrols. American submariners, while certainly facing danger and stress, lived in conditions comparable to shore duty regarding basic comfort. Japanese submariners existed in conditions that would violate modern human rights standards. Petty Officer Yukio Suzuki, who served on I-58, described daily life in his post-war memoir published in 1951. Interior temperature exceeded 100 degrees Fahrenheit throughout tropical patrols. Humidity was constant and everything was wet. Crew slept on thin mats on metal decks. Clothing never dried. Skin infections covered bodies within 2 weeks. They had no fresh water for washing. They used seawater for minimal cleaning, which left salt residue that worsened skin conditions. Suzuki wrote that food spoiled rapidly in the heat. Crews ate rice infested with insects, fish that had turned bad, and vegetables that had rotted. Drinking water was rationed to 1 cup every 6 hours. Submariners existed in constant discomfort. Constant hunger, constant thirst, constant pain from skin disease, and constant exhaustion from inability to sleep in the heat. After the war, Suzuki learned American submariners had air conditioning, hot showers, washing machines, ice cream, comfortable beds, and abundant food. He felt not envy, but rage. Japanese submariners had been told their suffering built strength. The Americans proved comfort built strength. Japanese command sacrificed crew health based on philosophical lies, Suzuki concluded. The comparative experience of submarine cuisine illustrated the broader disparity. American submarines carried varied provisions, including fresh vegetables and fruits for first 2 weeks, frozen meats adequate for entire patrol, bread baked fresh daily in submarine ovens, ice cream produced regularly, coffee, soft drinks, and juice available continuously, and vitamin supplements preventing deficiency diseases. Japanese submarines carried rice as staple, often infested with insects within weeks. Dried fish, frequently spoiled in humid conditions, minimal vegetables consumed within days, no refrigeration for meat, which was consumed immediately or spoiled, green tea as only beverage, and no vitamin supplements leading to scurvy and beriberi, common on extended patrols. The psychological impact of food disparity affected Japanese morale more than combat danger. Submarine warfare is inherently stressful with depth charge attacks, torpedo failures, and equipment casualties. Both American and Japanese submariners faced these dangers with courage. But Japanese submariners faced additional adversary in their own submarines' conditions. Chief Petty Officer Robert Palmer, serving on USS Pampanito designated SS-383, participated in rescue of Allied POWs from torpedoed Japanese transport ship in September 1944. Among rescued were British and Australian prisoners who had been held in Japanese camps. Palmer's patrol report included observations about comparative conditions. The report stated that rescued Allied POWs were brought aboard from water. These men had been held in Japanese prison camps for 2 years under brutal conditions. When brought aboard Pampanito, they were amazed by the submarine. They could not believe Americans had air conditioning, hot showers, clean bunks, and abundant food. Several POWs stated the American submarine was more comfortable than their peacetime barracks. One Australian soldier, after showering and eating hot meal, said the Japanese who captured them probably lived worse than POWs did in their camps. Intelligence later confirmed through multiple sources that Japanese submariners indeed suffered conditions comparable to Allied POWs. The difference, Palmer noted, was that POWs were captives being punished, while Japanese submariners were their own navy's valued sailors. The psychological warfare implications were recognized by American intelligence. Beginning in 1944, the Office of Naval Intelligence produced leaflets for distribution to Japanese forces describing American submarine conditions with photographs of galleys, ice cream machines, and crew quarters. The intent was to demoralize Japanese submariners by showing them what their command denied them. These leaflets proved effective. Captured Japanese submariners frequently carried them, and interrogations revealed the psychological impact. One leaflet, showing American submariners eating ice cream, included captions stating American submarines demonstrate that comfort equals combat effectiveness. Japanese submarine base commanders ordered these leaflets destroyed immediately upon discovery, recognizing their psychological danger. The human experience divergence extended to liberty and rest periods. American submarines returning from patrol sent crews to rest facilities designed for recreation and recuperation, including comfortable housing with air conditioning, recreational facilities with sports, movies and entertainment, excellent food and drink, medical care addressing any patrol-related issues, psychological counseling available for combat stress, and a 2 weeks minimum rest before next patrol. Japanese submarines returning from patrol kept crews aboard submarine during port periods, provided minimal shore leave, typically lasting 24 to 48 hours, had no dedicated rest facilities, offered inadequate medical care for patrol-related illness, provided no psychological support, and allowed maximum 1 week before next patrol assignment. The cumulative effect was that American submarine crews maintained effectiveness across multiple patrols, while Japanese crews deteriorated progressively. American submariners could sustain 6 to 8 war patrols before requiring extended shore rotation. Japanese submariners frequently became combat ineffective after 3 to 4 patrols due to cumulative physical and psychological damage. Commander Mochitsura Hashimoto, who sank USS Indianapolis with I-58 in July 1945, later wrote about the human cost of Japanese submarine conditions. By 1945, experienced submarine crews were rare, not because they died in combat, though many did, but because they became physically and psychologically incapable of continued service. The conditions destroyed men's health. Heat exhaustion, skin disease, malnutrition, and sleep deprivation accumulated across patrols until men could not function. Hashimoto wrote that he watched strong young sailors become shadows of themselves after 2 years of submarine duty. Americans rotated crews regularly and maintained their health. The Japanese ground crews down until they broke. By war's end, Japanese submarines operated with increasingly inexperienced crews because experienced men were physically ruined. Americans maintained veteran crews throughout the war. This was another advantage Japan could not overcome. Hashimoto concluded, "The American submarine campaign in the Pacific achieved strategic victory through industrial and engineering approaches that Japanese planners had dismissed as weakness. By war's end, the statistics demonstrated complete American dominance, driven substantially by crew effectiveness, advantages stemming from environmental control." Final. Pacific Submarine War statistics from December 1941 through August 1945 showed American submarines deploying 288 boats in combat operations, with 52 lost to all causes, representing 18% loss rate. They sank 1,314 Japanese merchant ships totaling 5.3 million tons, along with 214 Japanese naval vessels. American submarines achieved 16,200,000 combat patrol days with average of 8.2 war patrols. Per submarine before loss, or war's end, Japanese submarines deployed 175 boats in combat operations, with 128 lost to all causes, representing 73% loss rate. They sank 184 Allied merchant ships totaling 907,000 tons, with minimal Allied naval vessels sunk. Japanese submarines achieved 3,920,000 combat patrol days, with average of just 2.1 war patrols per submarine before loss or war's end. The disparity was comprehensive. American submarines achieved nearly 7 times the sinking tonnage while losing 1/4 the percentage of boats. The operational patrol day ratio of 16.2 million versus 3.9 million revealed how crew effectiveness enabled sustained operations that Japanese submarines could not match. The post-war analysis by the U.S. Strategic Bombing Survey, published in 1946, identified crew performance as a critical factor in submarine campaign success. The survey stated that American submarine effectiveness derived from multiple factors, but crew performance under extended patrol conditions was fundamental. Environmental control systems, including air conditioning, freshwater production, and food preservation, maintained crew health and alertness far longer than Japanese crews could sustain. Japanese submarines possessed technical capabilities comparable to American boats in many respects, but crews degraded rapidly under harsh internal conditions. American crews maintained peak performance throughout 2-month patrols. Japanese crews became ineffective after 3 weeks. This difference determined campaign outcomes more than any other single factor, the survey concluded. The Japanese Naval General Staff's post-war assessment, translated in 1948, acknowledged the philosophical failure. The assessment stated that Japan believed warrior spirit could overcome material disadvantage, that they assumed suffering built strength, and that they designed submarines prioritizing weapons and range over crew comfort. These assumptions proved catastrophically wrong. The assessment explained that Americans understood submarines are crew-operated systems where human performance determines effectiveness. They invested heavily in crew comfort, not from softness, but from recognition that comfortable crews perform better than suffering crews. The Japanese called American ice cream machines evidence of decadence. They were actually evidence of sophisticated understanding that morale affects combat capability. Japan's submarine campaign failed, not because Japanese submarines were inferior, but because Japanese crews could not sustain combat effectiveness. The Japanese destroyed their own crews through harsh conditions they believed built strength. Americans maintained crew effectiveness through comfort the Japanese believed created weakness. History proved Americans right and Japanese wrong, the assessment concluded. The lessons extended beyond submarine warfare to broader military philosophy. The Pacific War demonstrated repeatedly that industrial capacity and engineering solutions to human factors, problems, provided decisive advantages. American forces consistently outperformed Japanese forces, not through superior individual courage, as Japanese forces were as brave as any, but through superior systems maintaining effectiveness. Yet, remarkably, some Japanese military theorists never accepted these lessons. Post-war writings by former Imperial Navy officers continued arguing that warrior spirit should triumph over material comfort, that American victory proved only that overwhelming industrial capacity could defeat superior fighting spirit. These arguments ignored evidence that American fighting spirit was at least equal to Japanese spirit, simply better supported by engineering. The submarine veterans told different stories. Lieutenant Commander Zenji Orita, who experienced both Japanese submarine conditions and observed American submarines after surrender, wrote in his 1976 memoir about spending 30 years after the war thinking about submarine warfare. The conclusion is unavoidable, Arita wrote. Americans won because they understood warfare better than the Japanese did. The Japanese thought warfare was about courage, discipline, and willingness to suffer. Americans thought warfare was about engineering systems that keep crews combat effective. Both American and Japanese submariners showed courage, Arita noted. Both faced death with dignity. The difference was that American courage was supported by ice cream machines, air conditioning, hot showers, and clean bunks, while Japanese courage was unsupported by anything except orders to endure suffering. When Arita first learned American submarines had ice cream makers, he thought it proved American weakness. After the war, he realized it proved American wisdom. They understood that human beings perform better when comfortable than when suffering. This seems obvious now. It was revolutionary then. The Japanese never learned it, Arita concluded. The technological legacy of American submarine environmental control extended well beyond World War II. The air conditioning systems, freshwater production, and crew comfort features pioneered on Gato-class submarines became standard on all subsequent submarine designs. Modern nuclear submarines trace direct lineage to World War II innovations in crew habitability. The Soviet Union, examining American submarine designs through Lend-Lease boats and post-war captured documentation, adopted many American crew comfort principles. Soviet Cold War submarines included air conditioning, improved crew quarters, and better food service than had characterized Russian and Soviet submarines previously. The Soviet Navy explicitly studied American World War II submarine designs when developing post-war boats. Ironically, Japan's post-war maritime self-defense force submarines adopted American habitability standards completely. Modern Japanese submarines include comprehensive environmental control, comfortable crew quarters, excellent food service, and all crew comfort features that the Imperial Navy had rejected. The submarines today defending Japan implement exactly the philosophy that Japanese naval theorists once dismissed as weakness. The industrial capacity that produced submarine air conditioning systems represented broader American manufacturing dominance. The same industrial philosophy that concluded comfortable submarine crews performed better than suffering crews also concluded that bomber crews needed heated flight suits, while Germany expected pilots to endure cold, that tank crews needed reliable radios, while Germany believed disciplined substitutes for communication, that infantry needed adequate food rations, while Japan expected soldiers to endure hunger, and that all forces needed regular rest rotation, while Axis powers expected warriors to endure exhaustion. In each case, American forces engineering away human stress factors outperformed Axis forces attempting to overcome stress through discipline. The pattern was consistent. Engineering solutions to human factors, problems proved superior to relying on willpower to overcome adverse conditions. The final word perhaps belongs to Vice Admiral Charles Lockwood, Commander Submarine Force Pacific Fleet from 1943 through 1945. His post-war memoir, published in 1951, reflected on the submarine campaign. Lockwood wrote that Americans won the submarine war through industrial capacity, engineering excellence, and understanding that submarines are only as effective as their crews. Japanese submariners were as brave as Americans. Their submarines were technically sophisticated, but they couldn't keep crews effective on extended patrols because they designed submarines around weapons instead of crews. American air conditioning systems seemed like luxury to Japanese officers who examined captured boats. To Americans, they were weapon systems as important as torpedoes. Comfortable crews stay alert, make better decisions, and execute attacks more precisely. Suffering crews deteriorate. Americans engineered away suffering. Japanese philosophy celebrated suffering. Engineering defeated philosophy, Lockwood concluded. The ice cream machines symbolized the different approach. Japanese command would never waste resources on ice cream. Americans understood that crew morale affected combat capability and ice cream boosted morale. Japanese submarines had slightly better torpedoes. American submarines had ice cream. The American approach won. The lesson is simple, Lockwood wrote. Warfare is human activity. Human performance depends on physical and psychological factors. Engineering can optimize these factors. Nations that engineer for human performance will defeat nations that rely on willpower to overcome adverse conditions. Americans proved this in the Pacific. The lesson applies to all warfare.